Bismillahirrahmanirrahim. In today's lesson, we are going to talk about electromeric effect. So, electromeric effect is observed in those compounds which have multiple bonds. For example, alkenes, alkynes, and carbonyl compounds. And electromeric effect is a temporary effect and it occurs only in the presence of a polar region. So if we see alkenes, normally alkenes are non-polar. So this is alkene. Alkenes are non-polar, but in the presence of a polar region. In the presence of polar region, what happens? This pi electron is shifted towards one of these carbon atom, either towards this carbon atom or towards this carbon atom. So this bond is pi bond. Whenever you see multiple bonds, either double bond or triple bond, then there is one bond is sigma bond and the rest are pi bonds. So this was a pi bond. How was this formed? This was formed by the sharing of electron. One shared electron was provided by this carbon atom and the other was provided by this carbon atom. So now both of these electrons are moved towards this carbon atom. So now what happened? This has gained his own electron. One electron was his own electron plus one extra electron of this carbon atom. So this carbon will carry a negative charge and this will carry positive charge because it has lost one of its electron. So it will become, so now this system has become highly polar because it has charge separation. It has two poles. One pole has plus charge and the other has negative charge. And the electromeric effect is a temporary effect. It is observed only in the presence of a polar region. As soon as we take out the polar region, the pi electrons again come back to their original position and the molecule behaves as pi bonded system. So what will happen to this molecule in the absence of this region? This pi electron will come towards this position and we will get this pi bonded system. Similarly, the electromeric effect is also observed in carbonyl compounds. We know that carbonyl compounds are those compounds which contain carbon oxygen double bond. So in the presence of polar agent, these pi electron, the electrons present in pi bond are called pi electrons, are moved toward this oxygen atom. So now this carbon carries positive charge and the oxygen carries negative charge and the system behaves as highly polar system because it has two poles. One carbon has plus charge and the oxygen has minus charge. Electromeric effect is represented by the symbol E. We represent it with this symbol, and electromeric effect is non-directional. What do you mean by non-directional? Non-directional means that these pi electron can go towards either carbon, either towards this carbon or towards this carbon atom. So that is why electromeric effect is generally non-directional. But in the presence of a group, if there is a group attached to this carbon which have either plus I or minus I effect, then the electromeric effect has some directional. For example, if we have this compound, now we have this group attached to the carbon atom bounded by double bond, and we know that CH3 has plus I effect. It releases electron towards carbon atom. So this carbon will carry a slightly negative charge because it has gained some of electron density from this bond. So now these electrons will not move toward this carbon atom. These are always going to move toward this carbon atom because this carbon already has some negative charge. So electron don't like to go towards the same charges. So this will go toward this carbon atom. So in this case, the electromeric effect has become directional. It is going to, electrons are going towards this carbon atom. And similarly, if we have this group attached to the carbon bounded by multiple bond, and we know that chlorine has which I effect, either plus I or minus I. Chlorine has minus I effect. It removes electron from this carbon atom. So it has minus charge, partial negative, and this has partial positive charge. So now in this case the electrons are going toward this carbon atom. So as electromeric effect is temporary effect, it is observed only in the presence of a polar reagent. As soon as we take out the reagent, the pi electrons are shifted towards its original position and we get the pi bonded system. So as it is temporary effect, it does not affect the physical properties of a